Today we're going to be looking at proportions and problem solving. Our first example is to solve for y, and we're given 20 divided by y equals 4 over 5. Well, we cross multiply and set the products equal, so 20 times 5 equals 4 times y. 20 times 5 is 100. We don't want 4y, so we divide both sides by 4, and we find that y equals 25. Now we have a little different, but we certainly can do it. We have x minus 1 divided by 6 equals x plus 3 over 2. Again, we're going to cross multiply and do 2 times the quantity x minus 1 equals 6 times the quantity x plus 3. Distributing that 2 to each piece inside, we find that that's 2x and a negative 2. And the same thing on the right side, we distribute that 6 to the x and find 6x and 6 to the 3, and we find that's 18. Combining like terms, we take and add 2 to both sides of the equation, and we find that we have 2x equals 6x plus 20. Subtracting 6x to both sides of the equation, we get a negative 4x on the left, and we still have our 20 on the right. But we don't want a negative 4x, we want x. So we divide both sides of this equation by a negative 4 to find that x equals a negative 5. Our next problem is 2 boxes of candy cost $16.24. How much should 8 boxes cost? So we're going to set up a proportion. Let x be the price of 8 boxes. So we have our 2 boxes of candy costing $16.24, and we want to know how much our 8 boxes cost. So we cross multiply, we find that that's 2x, and 8 times 16.24 is 129.92. But again, we don't want 2x, we just want x. So we divide both sides of that equation by 2 to find that our x, our price of our 8 boxes of candy, is $64.96. Now we have 2 right triangles that are similar, and the legs on the first triangle are 3 inches and 4 inches. What is the length of the other leg of the second triangle if one of the legs is 6 inches? Well, we'll let x be the length of the unknown leg in the second triangle, and we set up the ratio from our first triangle as 3 to 4, and we know the one leg of the second triangle is 6, and we're letting x be the length of the unknown leg. So we cross multiply, and we find that's 3x, and 4 times 6 is 24. Again, we don't want 3x, we only want x. So we divide both sides of our equation by 3 to find x equaling 8, and since we're working in inches, it is 8 inches. Our next problem, we're asked to find a number, the quotient of a number, and 6. The quotient of a number means to divide, so we're letting our number be x. So it's x divided by 6 minus 1/4 is the equal sign. The quotient of the number and 8, so there's our number divided by 8. So now we have our equation, and we're going to solve by multiplying by the LCD. We multiply by 24, which is the LCD of 6, 4, and 8. 24 times x divided by 6 is simply 4x. 24 times a negative 1/4 is a negative 6. And 24 times x divided by 8 is 3x. Combining like terms, we're going to minus 4x to both sides of our equation, and we're left with a negative 6 being a negative x. But we don't want a negative x, we want a positive x, so we multiply that whole equation by a negative 1, and we find that x is just 6. Our next problem is we have Joe and Gary work together to make a table. Joe can make the table in 5 hours, and Gary needs only 2 hours to complete the same table. They are asked to make a table together. How long will it take? So we have to think about this. Joe completes 1/5 of a table in 1 hour, while Gary completes 1/2 of a table in 1 hour. So let x be the time in hours it takes for both of them together to complete the table. Then the equation is 1/5 from Joe, what she makes in an hour, and then plus 1/2, because that's how much of the table Gary makes in an hour, equals 1/x. So we multiply by the LCD of 5, 2, and x, and that is 10x. So when we multiply 10x times 1/5, we find that's 2x, and 10x times 1/2 is 5x, and 10x times 1/x is simply 10. Combining like terms, we find that 7x equals 10, but we don't want 10 or 7x, we want 1x, so we divide both sides by 7, and we find that x equals 1 3/7. And since we're working in hours, it will take them 1 3/7 hours working together to make a table. Our next problem is a car that's traveling 90 miles in the same direction a truck travels 150 miles. If the car's speed is 20 miles per hour slower than the truck speed, find the speed of both vehicles. Well, we know distance equals rate times time, or distance divided by rate equals the time. So let x be the rate of the truck, then the rate of the car is x minus 20, because it tells us up here that the car's speed is 20 miles per hour slower than the truck. Then the truck's time is 150 over x, and the car's time is 90 divided by x minus 20. Since the time is the same time, we can set them equal. 150 divided by x equals 90 over x minus 20. Cross multiplying, we get 150 times the quantity x minus 20, and 90 times x is simply 90x. And excuse me, distributing that 150 to the x, we find that's 150x. And 150 times a negative 20 is a negative 3,000. We take the 150x over to the other side by subtracting 150x, and we're left with a negative 3,000 equaling a negative 60x. We divide both sides of that equation by a negative 60, and we find that the truck speed is 50, and we know it's miles per hour. And the car, of course, we set that as x minus 20, which would be 50 minus 20, or 30 miles per hour.